Hello and welcome back. So this week we're going to talk about Lab 11, and as you can see, we've finally made it to the bottom of the folder here. This is actually not too bad of a chapter. It's pretty short. I mean, the chapter itself is about the same, but you only have 3 exercises to do this week. So watch your lecture, and then this week we actually have an additional video here. It's a sheet metal concept video. All it is really talking about the principles of sheet metal. And then this lecture, I will have a modeling concept for the same sheet metal stuff. So you'll kind of get to see 2 disciplines by watching both of these. And then, after that, do your discussion board, and then you'll be doing every exercise for this one. So I'm going to go ahead and jump into it, and we'll just look at the guided tutorial together and talk about it. So the first thing it does here is a little bit of a demonstration talking about more sheet metal fun. It doesn't seem like a big deal, but sheet metal is used everywhere, which I'll touch on in the concept video. But definitely make sure you're on your A game for this one. You'd be surprised that you're gonna be doing sheet metal work all the time. So yeah, it talks about all this math behind it, but since I covered it in the other video, I won't bother. But you're pretty much going to recreate this drawing, so when you're done it should look just like this. And with a part like this, there's a lot of ways to make it, but they start with making a sheet metal part. Make sure you're on the sheet metal one, not the standard. Otherwise you'll have to do a conversion, which I'll show in the hands-on part of this video, but take note of that. And then it has you go through and play with the sheet metal defaults and change the settings to what they want you to do, which is various thicknesses, different types of bends, and even relief cuts, which actually I'm going to flip back to that. Over here you have how they make a bend. Sometimes when you're doing a bend, there's, like in real life, if you try to bend something and there's not a seam, then how could you bend it? They would make a cut, which would then allow it to be bent, and that's what those are, is relief cuts. So they have different shapes as you play with those a little bit. Now this is an interesting part too. So when you work with a regular part, usually you extrude it however thick you want, and that's that. But with sheet metal, you use the face command instead, so there's no need for that. It pulls the default, so you're only just clicking a profile and it makes a shape. So sheet metal works almost completely different, which it's a whole discipline in itself. But you're gonna have to get familiar with those tools, and I'll try to demonstrate all those. And let's see, it's pretty straightforward. A lot of people end up having some issues with this one, but you're pretty much just doing a bunch of flange commands and adding on. And in this case, they model this little wing over here, mirror it over, and then they have you draw, they have you do some cuts, then they have you draw a line, and you use that line to actually fold the part. You can kind of see like a preview there, which is a strange shape at that point, but yeah, pretty cool tools. And then you probably would think it'd be hard to make a flat pattern, but you just hit go to flat pattern and it makes it. So, and this is a good thing to mention too. So when you're going through all these, always measure. Make sure your stuff's coming up right, And then you're plenty familiar by now with drawings, but you're going to do a drawing detail. You're going to have your 3 views, an ISO view, and then the flat pattern to detail. And it seems like a lot of people take the initiative and do what they want, but just make sure you're capturing all these details. You should have every dimension they have, the notes they have, and your title block doesn't have to be the same, but if you went ahead and saved the one from a previous chapter, you could have the same one. Okay, so this guy, this one's kind of a pain for some people, but I feel like I did a pretty good job of explaining it in a solutions video. So you're always welcome to reference that. Shameless plug. It's good stuff. But little hint here for you. You don't have to draw all of these little circles. You could just draw one set and do a circle pattern. That would be a lot easier. And same with the flanges even. Technically, you could create one of these flanges up here and pattern the other 3. So try to work smarter, not harder with it. And then this one, obviously this should take no effort. The biggest part will be detailing it, and I think in my solutions video I didn't have details, so make sure you got your 2D drawings as well. Kind of flip-flops in the chapters what you have to do, but keep that in mind. And yeah, so that's going to be it. It's a really basic week, so I'll go ahead and hop in Inventor and just show off some stuff. So first things first, I'm going to open up a sheet metal part and a standard part and show the difference, so you can kind of tell which one you're in, because sometimes you may forget. So first, let's go to the sheet metal part. So if you notice, there's a special tab here, sheet metal, and this one doesn't have it. But when we're on the 3D model tab, we have this convert panel, would convert to sheet metal on. So that's going to be your telltale way to know which you're on, because you know you've got different ribbons. It's one thing I haven't talked a lot about, but each part type, assembly, you know, new part files in general, they all have a different environment, and you know, so the ribbon tells you what you're in. Basically, is the moral of the story. So say I started a part in the wrong one. I've already made it, and like I'm committed. I don't want to redo this whole thing. You know, the way you can fix that is just to hit convert to sheet metal, and it'll actually make it where you can do the sheet metal defaults and stuff. But there's one more way to tell too, and I want to mention it. If you go to parameters on a new part, it's empty. But if I go to a standard sheet metal one, it has all of these parameters given to you. And what these are is they're like the absolute mirror of the sheet metal defaults. If you go in sheet metal defaults, each one of these exists, and you can actually edit them in sheet metal defaults, and they'll be updated here. Now you can't edit them in the parameters. I don't know why, but you know, keep that in mind. So, you know, I could convert this one, and now we've got the same ribbon. We've got the parameters. So now, for all intents and purposes, if I were to undo, you can also see the icon changes. So for all intents and purposes, now I have two sheet metal templates. So I'm just going to close one. And I'm just going to draw, you know, like a really basic shape. I'm just going to do something like this. Really random. And then I'm going to change sheet metal defaults to be, well, I probably should see how big this is. Okay, that's really small. FYI, if you're having problems though, when you make a sketch, a lot of times it shows folded. Just, you know, expand it. For whatever reason, they like to have a folded model and a flat pattern, you know, expander, whatever you want to call that. So let's put some dimensions on this. There we go. And for the heck of it, we'll put an angle. Okay, so now I've got this sketch. The easiest one for a lot of people when you're doing a basic shape like this is going to be a contour flange. But I'm going to change our defaults. Now, always keep this checked. The thing you want to do to start editing is hit this little pencil that says Edit Sheet Metal Rule. In the chapter, it has you create a new rule, but you're not editing some kind of global setting. This is just like in the part, its rule. So there's nothing wrong with editing it. And then, you know, you would want to change it to still mild. And as far as I can tell, this actually doesn't really seem to change anything, but just in case, it's always good to have it. And I'm going to make our part 0.25 thick. We won't have a seam, but I'm going to put 0.125, which is half of the thickness, just for the heck of it, just in case I get crazy later. We're going to change the bend to say thickness plus 0.125, and that's right. You can actually have a formula here. And all this is that inside bend radius. If you're looking at kind of where my mouse is, you know, like where it would bend up. And, you know, this is just a rule of thumb I got from where I used to work. You know, usually they can not bend that effectively. So we always had like an 1/8 cushion on it. So I'm just going to do the same here. And then we're going to leave relief as straight. You know, you could do other things. Tear is kind of helpful sometimes. But I'm going to hit save. So now we've got that. And all I have to do to make this flange is just click contour flange, and just like that we have a shape. Now I showed this in our concepts video as well, but basically what happens is when you model something, it creates the bends where it needs to based on the given information. What you're seeing at this point right here is technically the outside setback. But you know, you probably already know that at this point by watching. But what's cool is like when you use a contour flange, it actually gives you some pretty good flexibility. You know, if I were to change this to 90, it actually changes too. All based on a single line sketch. It's pretty cool. One thing you can also do, if you're like, oh no, it's on, you know, the wrong side, you can always change it to be on the other side of the line or halfway both ways, which, you know, typically it's probably going to be one or the other. You know, like you're probably meeting some shape up, trying to, you know, mate two areas together. So it kind of works to typically be one of these two, but, you know, you have options. So that's one thing you can do. If I were to just go and suppress this, start another sketch, let's say, let's do something like this. Just a random shape. Imagine it was dimension 2 perfectly. So using that face command, and apparently this is really little. I keep doing that. Let's just scale it all up. And it didn't. Sad. I hate how sometimes just one spot will scale and not the others. See, like dimension there and it works fine. But anywho, so now if I were to do face, it's going to create that same depth from our sheet metal default, this 0.25, which we controlled here. And, you know, I could verify that with this dimension. And that works fine, you know. One of the things you can do from there is flip the face either direction as well. You know, it's a big focus is flipping the faces as needed. So you can kind of see with the arrow and a little bit of the preview, the green box, you can see where it's going. Technically, if you had bends, you would add them in here, you know, but it's going to default to that default setting we chose, which is going to be thickness plus 0.125. And then I really don't ever use these two options, to be honest. It's pretty fine as is. But one cool thing, and I really don't use them all that much, but you can do some features from this modify tab. So I could do corner rounds, and it's the same thing as a fillet. You know, except for it shows up with the sheet metal features. What you'll find is when you're working at a company, a lot of them, you know, they require you to do things a certain way to help their cutter properly cut out stuff. So sometimes, like, you may not be able to do anything but sheet metal features. Otherwise, it may not even acknowledge them and it may not cut them. In that case, you would be using these corner rounds and fillets. But honestly, you know, in my experience, Inventor's pretty chill. So you can still just put in your fillets and odds are it'll be fine for work. But obviously that's on a different tab. So, you know, you're welcome to try to use these features as well. And the same for the corner chamfer. You know, you've got it. And, you know, obviously you're familiar with the hole tool. I'll show you the unfold and refold and the rip. Okay, so let's do a cut. So, you know, you're familiar with an extrusion. Obviously you can extrude cut out something. But you can also use cut. Now, cut is great because of this option right here, cut normal. It's hard to really explain without showing you, but cut normal is meant to cut something so whenever you have it lay flat, the hole works properly. It's mostly ideal for circular bodies, and I guess I will show you here in a second, but for now on this one, it's pretty basic. So how about we'll suppress this guy as well. And what I'm going to create is a pretty standard shaped thing. Basically, it's what you know, any kind of tank would probably have. It's just a rolled piece of plate. Now, this is the tricky part. So say you had something like this and you know it's going to be a piece of plate. You would have to type in the value thickness. Now, this is, you probably wonder where that comes from. This is from that same thickness that we had earlier, you know, from the sheet metal defaults. So you would have to like assign that value to say like this should be the thickness of metal. And then I'm just gonna make this huge. I'm gonna finish it. And in this case, you know, you really don't have much choice but to do the extrusion. So this is what I was talking about. You know, you kind of have to hybridize things sometimes, but I'm just going to give it like 8 feet, 96 inches. Now, if I were to go and draw from the origin on this face, just some random circles here. This is where cut comes in handy. So I'm going to do a through all, up, cut normal. I didn't like that. Why didn't I like that? Let's see. I bet it's because they're not on center. You know, it's still kind of hard with sheet metal sometimes to get it to work right. Okay, let's try that again. Huh. Wouldn't you know? Let's just try doing a generic distance. Sometimes it's weird about that stuff. Yeah, so it's gonna work if I do a distance. So let's try doing 2 next. It's basically not recognizing the boundary. So in this case, you have to put a gross number in there and call it a day. But I'm gonna do a cut normal on it, and I'll choose this other profile too. Oh, it still didn't do it. Sad. Okay, well this is a rare scenario where this happens. You know, I've experienced in some versions of Inventor where when you try to do certain things, it doesn't work for certain arc sizes. So I'm going to try to change some numbers just as a last ditch effort here. Try to give you some kind of example. Let's go smaller, and let's try this again. Yeah, I guess it's just not gonna work. Sad day. Well, you know, that's the typical way I've done it. It's clearly not wanting to work, but I'm gonna leave it for now and show you what a rip is, and maybe it'll work when I put the rip in. So what a rip is a seam. Now, when you're making a part like this, if it were sheet metal, you know, obviously it's supposed to be flat, but if I hit create a flat pattern, which is how you make one, by the way, it just says I can't do it. No way, impossible. Well, that's because you need a seam. Obviously, if you've got a piece of plate, it has to have an ending and a beginning to be unfolded so that it can actually be created. And this is one of those things where you really have to think about actual creation. So you would use a rip, or you could also manually draw the cut, which is just silly. So it's ideal to use a rip. So I'm going to choose the outside body, the cylindrical face, which I've already selected. And then at this point, you know, you would need a point. I forgot about it. So I'm just going to draw a sketch on the end face. And I'm going to put it on the left side here. So I'm going to project geometry, make a point, just out in space, do a coincident, and a horizontal constraint from the origin to that point. Okay, so now I've got that. And I can go to the rip, click on the outside body and the point, and then right there you can see that seam. Now, when I was talking about changing to 0.125 on the miter gap seam, this is what I was talking about. But you can see what it does is it chooses that face and the point, and it projects all the way through the part. Technically, I can choose the location. Right now it's centered on this point, so it's equidistant both ways. But I could make it start at that end or end at it. But I'm going to do centered. And there we have it. So now if I were to hit create a flat pattern, it actually unfolds it. And you can see that what this is a giant square that they then roll, with this being the center line. Pretty cool if you ask me. I'm going to sneak in and try to do this cut again, see if it works. I just can't believe it because this is like something I do all the time, but it doesn't seem to want to work. I did it. There we go. See? Okay. So in that case, what you probably need is you need to make sure there's a seam before you go playing around, basically. Like I should have. Okay, so now when you're looking at it, you know, you've got these weird edges, and this is what happens when you do like an arc on an arc. Obviously, things are weird. I played around with this for a long time back in the day, and I used to draw I would make everything flat and I would model up the holes on a flat pattern, you know, not this flat pattern, but like I would truly model it flat and then roll it. And what I found was I would model these in and I would make sure to use, you know, arc length and get them located properly, and it just never lined up right. Never. And it's because you basically need to use cut normal. If you notice when we're looking at this is a perfect circle, and so is this one. You wouldn't expect that, but they are. And the reason being is whenever you're making something like this, if you're actually making it flat, nobody can cut a hole that's like really oblique, you know, just like a broken hole. They need a perfect circle. You know, it's something easy to cut out. So what cut normal does is it makes it where when it's flat, it's a perfect circle, and then you get the shape here. Now, granted, sometimes the holes end up with like these quadrant lines, you know, where you have different faces. And that's fine. You really can't help that. That's just something Inventor is calculating and doing. You know, this isn't an engineering thing. You know, this is just Inventor has this math behind the scenes it's doing, and there's no reason for you to really mess with it. You're just kind of creating these parts and not worrying about the semantics of why it is you have one phase here and two here. You know, it's just one of those things. But what this allows you to do is then like stuff a pipe in there or whatever, because now you've got holes. And you know, obviously the cut command, this is the way you want to do it. If you're gonna make holes in a cylindrical object, do not use extrusion. Make sure you're doing cut with normal turned on. Now, so that's pretty cool or whatever, but you know, say we didn't have this rip. I'm gonna suppress it and it's gonna scream at me. It's gonna keep screaming because now we can't have a flat pattern. What's cool is like you can ignore that the flat pattern's broken and just keep moving on. You can also just click on it and delete it and then add it back with, you know, click of a button. But I wanted to show also how you could do a rip manually if you did want to, for whatever savage reason. You could do something like this. And the idea is you want, you know, when you're looking at sheet metal, it's supposed to have like this straight edge, you know, always. So what you would do, I take that back actually though. What you would do is draw two lines parallel to each other, and then you could manually go in and type in gap size, and that's Pascal case, just like when you're looking at the parameters for it. It's gap size. Now this is a lot more work, but for some reason some people do this, so I'm just pointing out that you could do it this way. I wouldn't exactly say do it this way. You could go and make this symmetric, and then unfortunately all of this got dragged way out of the way, so I'm going to pull it back up to the, well, I was trying to pull it up here. There we go. Do the same with this. Ugh. Let's just give these a size so it's a little easier on me. Oops. And this is why times like these it's nice to have construction lines, so you can tell what you're looking at a little better. So I'm going to make these horizontal. And you know, say I went through and constrained this in place. I usually just like to trim. Ooh. That did not go well. Got to delete the dimension. So now I could go through and trim. I don't know why we're getting these little points here. Okay, so now we've got that. And what you could do is go through the same process. You could do a cut or an extrusion in this case. Choose this area, do it through all, and you end up with that same cut. So now we've got that. So if I were to go to flat pattern, we've got that flat pattern still. But if you notice, that's a lot of work versus doing just a simple rip. So, but you know, sometimes when you're working with really complicated parts, you actually cannot get the rip to work. At which point you're going to have to manually make the cut. So you really need to know how to do it, even though you wouldn't expect to. Now, one thing you can do instead of a regular flat pattern, and this does have uses, it may not seem like it does at first, but the unfold and refold, you can manually unfold it. So in this case, I would select a plane and then, you know, the body. And what it does is it shows a preview of it being unfolded. Now keep in mind which plane you choose, because you have to choose the same ones when you refold later. But what this allows you to do is unfold it. You could go and make a cut on it. We'll do like a cut here. I'm just gonna do it through all. Okay, so say we did that. Now I could refold it, choosing the same inputs that this right plane is the one I chose, and then the base. And now what we have is this part shape again, but we've got a feature in it. So this is another way that you can draw a part detail flat. You know, like say you had a logo. You could go and unfold it, add in the logo, and then you could refold it and have it shaped right with the logo on it. It's a pretty cool little tool. And again, when you're working with more complicated parts, you may have to manually unfold it like this. So it's good to get in the habit of practicing with it. But then you still have to go and hit create a flat pattern and have the flat pattern. So, I mean, it's not perfect, but it is definitely helpful. And let's see here. So let's just go ahead and ditch all of this. We're going to play around with the flanges here. Maybe some folds. There's quite a few options for this one. Wait for it. Okay, so say we drew a part flap. Let's make it kind of big so we have something to work with. Okay, so you would do a face. Now you've got a shape. So now, what if we decided that this needs to be folded? There's various ways you could do it, and it depends on how you want to go about it. I'll show you the one I don't usually like to do the most, but it works fine, I guess, technically. It's a fold. That's the one I show off in the chapter. It helps because, you know, you're taking information and just folding it. It's great when you're making something flat to start with. And I'm just going to trim some edges here. So let me project these. Okay, so if we decided to fold this part, choose this bin line, you immediately get these two arrows. So what it's saying is it's going to fold upwards and in this direction. So I'm going to try to just fold this little end down. So I'm going to hit flip, and then I need to hit the other flip because that flipped this arrow, the horizontal one, but we need to flip it to go also downward. So now what's going to happen is from here over, it's going to bend downward like that. Basically like this little arrow indicates. It's going to bend this half this direction. And then you have some options here. And this is really the bread and butter of sheet metal commands, is how to know where you're bending and for what purpose. So of course you've got your angle. I could bend at whatever angle I want, and it's going to give me the bend radius for it. But it's these three. Basically, from this bend line, I can choose to have it be centered one side or the other, just like with the seam, kind of, you know. And when you're modeling things, there's always going to be an intent. So maybe you want it to be a minimum of 4 inches, you know, on this side, and that's what you're going for. Or maybe you want it to be 4 inches overall. You know, you could choose that, whether it's a leg length, a flange length, whatever, and it's going to bend it to that. So now I chose the overall. So when I measure this, I don't get the overall value. That's because of the bend deduction in there. So, you know, a lot of times what I like to try to do is exclude that bending area. So now you know that the leg is 4. So, you know, if you know how to manipulate things, you can make numbers much easier to work with. You know, especially when you're working with a shop, 4.625 is a lot easier to work with rather than, let's see, what was it? It was a pretty random number. 3.863. Tell me on the tape measure where you see 3.863. You're not going to find it. So we did that. You know, that was cool. We took a flat part and we folded it. But you can also do the same thing, but without having to actually make the flat part. Flange. Flange is probably the king of sheet metal. All you do is choose an edge, and I'm going to choose, let's choose this one. We're going to bend it upwards. So from here, all it does is it cuts off what you would consider the outside setback. If you're looking at it, you know, you can see that's clearly the OSSB. And then it basically just gives you an option to give a length. So I could say it's 6 inches long. And then you have some other options. You can change the position where it bends from. So you know I mentioned here it could be from there. You can also move it to the end of the part. You could move it to where it's the inside face. You know, so you've got some options. I don't really think I ever used bend tangent side to face, but it's pretty much the extent, as you can see there. So actually that would be a great one to use probably. But the default is usually, you know, never the ideal one in sheet metal features for whatever reason. But this is, you know, in this case what we're going to use, it goes to the end of the face. And then you actually have some secret options that nobody really knows about, but you can go down here and hit this extra button, change it from edge to width. Now this isn't even a part that can be, you know, like made necessarily in this format, but oh, I was typing in the wrong area. I could change the width to be like 4. And then just like that, we have a transition from a size to another size. And then we'll make this 4. And there's one more thing I need to mention before I hit OK. So I'm going to close this back. It's height datum. So when you're doing the actual math behind where something should end, this is where this one comes into play. If you notice, my height changes when I switch these. So what you're getting is a measurement from a face to a face. So, you know, from this one, it's bend from the intersection of the 2 outer faces. So I'm assuming, you know, this is one of those ones I'd have to actually get measurements on to confirm, but I'm assuming it's this face to maybe this other face over here. But, you know, usually you end up having to toggle these around, and it's a lot easier when you have more definition to tell what you're working with. But, you know, you can easily have one of these 3 wrong or one of these 4. So what you're going to find with sheet metal is you're playing around with the settings a ton to get what you want. And you may even have to go into the actual options here, which as you can see are basically sheet metal defaults. So there's so much goes into it. But if you noticed, it had the options for corner relief, default trim to bend, and it actually put those in. So, you know, sheet metal's smart enough to know when it needs something, which is nice because now if I were to go and unfold this, it can still unfold because it's got that transition there. So, you know, there's a lot of power in the sheet metal commands. You just got to get comfortable with them. Just put the time in, and then once you have something the company that you're working for wants, you'll find out how to cater to those needs. You know, it's just a hands-on kind of thing. You know, we could also do a bend. Forgot about that. So, you know, I really don't ever do these. So I don't even know if I have really done a bend per se, but we'll give it a shot for the heck of it. So, no, I don't want to do it there. Let's do it on the... We'll do a sketch here. What I'll do is just draw something like this. I don't know if they have to be the same size or not, if we're being honest, but let's do a face. See if we can't do a bend from here. Well, I don't think it's going to work, if we're being honest. Shoot, it did it. Yeah, so if you say you had a couple of distinct things that you needed, like you know that this piece mounts here, this piece mounts down there, you could always just basically draw in those boundaries and then just say from edge to edge, you know, you want it to meet this end and this end, hit OK, and then it fills it in. Does all the extra work for you. So, you know, it's pretty intuitive. It's definitely not perfect, but it does the majority of the work for your needs. And I don't really use hems, but I'm pretty sure all you do is just click an edge and it puts a hem on it. Hems can be useful, but you know, you may never use them. I honestly never do either, so I won't even talk too much about them. But the idea is choose an edge and choose the hem type and you're golden. So we did contour flange at the start. So the last 2 we need to do are contour roll and lofted flange. Now lofted flange, I think I showed in a previous lecture, but I'm going to show it again just for the heck of it. Let's just move everything out of end of part. Okay, so lofted flange, pretty straightforward. All you're doing is drawing 2 profiles. And then, you know, in this case, what we would need is to offset a plane. I'm just going to do like 2. I'm assuming I drew it really small. I did. Oh, no. That's okay. I must have hit a wrong button. Alright, so now I can draw on this face, or plane, and do a smaller square. Turn off plane visibility because it's gross to see. And then all I do is choose profile, profile, and it fills in with the default settings. So if you do a top view, you can kind of see that we have the same deal where it's taking those theoretical points and making bends. And you know, if I were to zoom out again, I can choose the direction as before. So like, this is probably the common setup you'll have. You'll have a boundary and you'll have these cope to that boundary. There is one thing that I always suggest doing, and it's this: change it to die-formed. I guarantee you, where you work, they're not making this with a press brake, but they may be. Now you don't know what that means, but basically the difference is die-formed means it's rolled. You can see it looks very smooth. It only has a few edges. When I do press brake, what that means, I'll just hit OK and I'll undo it, but what that means is they're actually taking it and folding a piece of plate flat, like as if you were bending it, you know, like making that L-shaped kind of style plate. They're going to do it every single piece. They're folding it manually, which is really freaking hard to do. So I really doubt they're doing that, but at my old job they did do quite a bit of that. So you can't really tell too much in in this version because it's so small, but there is a big difference. And if you notice, all your options go away over here when you change that, because when you're doing a press brake, you're literally trying to determine how close to that tangency do you want. You can kind of see that. That's what the chord tolerance is there. You're basically approximating that general round shape with flat faces. Not great. So we're going to use die-form for like everything we do in this class. So now, you know, it looks a little bit better. You can tell there's less faces. You still have some weird curvature, as is customary with sheet metal. You can kind of see it just has like these weird shapes. And if you look at a top or a front view, it actually goes higher than it should. This is one of those things, when you get to crazy shapes of sheet metal, it might be that way. You just kind of got to roll with it. You know, I'll always let you know if you're on the wrong path with stuff like that. But it's just like a loft with just more settings. So the last one on the list is contour roll. Yeah. This is not something I use a lot either, if we're being honest, but I have used it a time or two. Let's see, let's try to draw something. How about if we had something like this? Let's turn this other sketch off. What I'm going to do is just trim out part of this. I think we can do oh no, deleted the wrong one. There we go. Okay, so now we got rid of all the junk. So I'm pretty sure if I just choose the profile, no. Okay, let's hover over it again. Okay, I take everything I said back. This is like a revolution. So if we were to take something like this, I don't know what we're drawing, but you would have to be very methodical and make sure that, you know, you end up with the same thickness here. I really don't know if this is going to work. If not, what I would have to do is basically add in a curvature, which I will, but sad. Man, see, this is one thing that sucks. Okay, so let's just delete this part. I don't want to waste too much time drawing silly stuff. Okay, so now we should be able to just choose this profile. Oh, my bad. Okay, so it's been choosing the axis first every time. It's one of the only things that does that. Okay, so now I should be able to choose the profile, and no. Well, okay, let's take a detour here and hit F1. Yeah, okay, so that's the problem. I've got too much detail. This is just like contour flange. Makes sense. Okay. So let's just delete this. Contour roll. There we go. Okay. Strange. I chose the wrong axis. But what you have here now is this edge being revolved around, just like the contour flange, but obviously revolve. So I could make this like 135 degrees, and there you go. This is actually kind of useful, come to think of it. Sometimes you'll have like a, you know, they call them quarter moon where I used to work, but like a round shape that fits to a pipe. And, you know, you could pretty easily replicate that shape with something like this, which is pretty useful. And, you know, same deal. You can flip your directions, whatever you need to do. And you can flip your angle position. So yeah, pretty cool stuff. Let's see. Other than that, I think it's going to be it. Just remember that you can create your flat pattern here. Actually, I take that back. There's one more thing we need to show. Okay, let me just make a flat pattern real quick. Okay, so say we had our flat pattern, which there's no fold, but say there was a fold. You know, you can basically choose your position of this part. So like, if we're going to our folded, our front view is this short face, okay? So we're looking at it like this. So say I go to my flat pattern and I want to detail it, you want it to be positioned the same way ideally. And that's where you can do right click on the flat pattern itself and do edit flat pattern definition. And you can choose a different edge and choose align horizontal or vertical. In this case, I'm gonna do horizontal, hit apply. And now when I go between folded and regular, which if I were to do front view for both, I guess, you know, I would still have to play around with it basically, but let's do it again. Let's choose this edge. Huh, it's not letting me click for some reason. There we go. Okay, so I could choose like this. Well, in this case, it's really only going to let you do it there, but that would be fine, honestly, because what this corresponds to at least is the top view. So I forget that when you're detailing, it still positions it a certain way, but you know, you can basically make it where when you place a new view in a drawing for your flat pattern, it's going to be in position in reference to the actual part. So keep that in mind. Right click, edit flat pattern definition, and you can choose either the length or the width or edge, and you can align it. So you cannot choose the depth dimension edge, but that's okay. No biggie. That's going to be it. If anybody has any questions about sheet metal, just let me know. I know it's kind of a strange topic, but, you know, it's one of those you really got to try to get good at because you're probably going to use it a lot. All right, thanks for watching.